All right, here we go. Let's kind of pick up where we left off yesterday. So we were talking about factoring, right? About using factoring as a way to solve quadratic equations. And so if they ask us to do something like completely factor something, what does that mean? And let's use as a quick example, let's just use a number. Like what if we took the number, come on. There we go. So if we took the number 30, and I want to completely factor that, you know how to do that. What would I do? So what could I use?
10 and 3.
10 and 3, okay. So I could do 10 and 3. The 3's done, that's prime, but the 10 would break up into
5 and 2.
5 and 2. Okay, and so then we'd end up with 30 equals the product of all three of those factors. So 2 times 3 times 5, right? That'd be completely factored. So we're going to do the same thing with an algebraic expression, right? We're just going to try to break this up into as many pieces as we can. So what's the first thing we can do? What do you think? Okay, we're gonna get to that, but there's always something we want to try to do that's easy first. Okay, good. So notice that all of these terms are divisible by 2. Do you see that? So we can undistribute a 2. So we're gonna always look for a greatest common factor. So if we undistribute a 2, what's left over? Well, we can find out if we're undistributing a 2, we're just dividing each term by 2, right? So for example, if I divide 2x squared by 2, what do I get? X squared. Another way to think about that, 2 times what is 2x squared? X squared. 2 times what is negative 2x? Negative x, and we can also get that just by dividing negative 2x by 2, right? 2 times what is negative 40? And the same thing, if we just divide 40 by 2, we get our 20, right? Make sense? So that's the first step. Okay, so we broke out a greatest common factor of 2. Okay, now our goal is, can we split apart this big quadratic factor, x squared minus x minus 20? Is that done, or can I factor that further? Can I split it apart into a product of 2 factors? So we can try. Either it's going to work or it's not. And in reality, when you're doing problems at the end of the unit, a lot of them aren't going to work factoring. So we're going to have to move on to the next strategy. Now, we don't know that yet, what the next strategy is, and so we're just practicing the factoring. If it factors, what would have to go there and there?
X.
X. And think why that is, right? Because when I FOIL this out, when I distribute, I would have to get an x squared for my first term. So the only way to make that happen would be with an x and an x, right? Okay, the question though is now magic numbers. What are the numbers that are going to work, if any, to make the rest of this stuff happen? So when we're looking for the magic numbers, what are they going to have to multiply to?
Negative 20.
Negative 20, right? They're going to multiply to the constant and add to negative 1. Whatever the coefficient of x is. And so there's an indivisible 1 there, right? So we get numbers that multiply to negative 20 and add to negative 1. Think about the signs. If they multiply to a negative, John, what can you tell me about the signs of the two numbers? That'd be different. One positive, one negative. Very good. Jade, which one's going to be bigger? If they're different signs, but when we add them up, we get a negative, which one must have been the bigger of the two numbers? Excuse me. Say it again. We know we have a positive and a negative because they multiply to a negative.
Oh, the negative.
The negative. Good. So we'll put that one first. So what are they? 5 and 4. Good. So negative 5, positive 4, and that is our answer. That's completely factored. Broke it all the way apart, right? Okay? All right. Let's try another one. Let's skip that one for a second. Let's do that one. So we're going to factor that expression. Okay, now, first things first, I want you to get a sense when you're looking at these things, I want you to think about this in terms of categories and strategies. I want you to think about this in terms of memorized stuff. So when we look at a problem like this, it's quadratic, it's got an x squared, but that one should look easier to you than that one did, right? This one's got more terms, it's a little trickier, right? We have to use magic numbers and do more stuff. Something that's only got 2 terms like that is easier. I don't have to do the magic number thing. At the most, all I'm gonna ever have to do if I have 2 terms is just see if I can factor out a greatest common factor. Can I undistribute anything? What's the biggest number that divides into 18 and 12? 6. Okay, so I could undistribute a 6 for the number. How about for the variables? An x. Good. Now let's think about why that is. If I write out, I'm going to write this in kind of a dumb way here. I'm just going to focus on the variables for a second. If I have something like x squared plus x, think what that means. That means x times x plus x. Well, how much could I undistribute? I could undistribute only, this one only has a single x to undistribute. Everybody see that? So I could undistribute that x, and what am I going to be left with? I'm going to be left with an x there, and if I divide this one away, I've just got a 1, right? Everybody see that? Let's try another one like that. What if we had, I'm going to make one a little harder one. Later on in the year, we'll do more stuff like this. Like what if I had something like x to the 4th minus 2x cubed plus x squared? What could I factor out of each of those? X to the 4th looks like this. X times x times x times x minus 2 times x times x times x plus x times x. So those are my 3 terms. How many x's could I undistribute at the most? 2. This one's only got 2 to give away, right? Everybody see?
Yes.
So my greatest common factor would be x squared, right?
Yeah.
So I could divide away those, I could divide away those, I could divide away those. I'm going to have some leftovers there, some leftovers there, and over here I'm just going to have a 1. Right? Okay. So, oops. Back to there. Okay, so we can factor out a 6, and we can factor out an x, right? Oops, wrong color. And what am I left with if I do that? If I factor out a 6x, what's going to be left here? 6x times what is 18x squared? 3x, good. Okay, 6 times 3 is 18, x times x is x squared. 6x times what is 12x? 2. Right, that's all I need. 2 times 6x is my 12x. Okay, so that would be factored. Right? How about something like that? So think back to the example we did just a second ago, back there. What did we try to do first on this one? Right? We always want to see if we can undistribute something first. If we can, that's always going to be a good idea, right? In this case, it's part of the answer. So we're going to try the same thing there. Is there something we can undistribute from each of those? 2 or negative 2. Which one is it? It's a good question. The answer is it's negative 2. So the GCF is negative 2. Here's the reason for that. So listen to this very closely so you can file this one away in your brain. When I write a quadratic expression like this, and I write it in standard form, right? So standard form is always going to look like this. It's always going to look like some number, call it a times x squared, plus some number times x, we'll call that b, plus some constant called c. Okay. In standard form, we always want to put the x squared term first. In fact, later on in the year, when we do bigger polynomials, we have x cubes and x to the fourths and all that stuff. We're always going to write them in standard form, so we do the biggest powers of x first, and we just walk down to the smaller powers from left to right. Okay? And eventually we end up maybe, not always, but in most cases we get a constant. We can get one that doesn't have any x's, right? So the rule is, when we're factoring out a greatest common factor, it's always going to keep the sign of the leading term, the term that goes first, the term that has the biggest power of x. So in this case, the x squared term is negative, so this one needs to be negative. Okay? So the negative 2 is the greatest common factor, then what's going to be left over from that? In the first term, negative 2 times what is negative 2x squared? X squared. Negative 2 times what is negative 22x? Good. Negative 2 times what is negative 20? Good. Okay, so there's step 1. Step 1 is always going to be try to factor out the greatest common factor, right, GCF. And that's the same thing, we might call that undistributed, right? Okay, now we do what we practiced yesterday. Now we've got this other factor here, x squared plus 11x plus 10. We look for magic numbers. Okay, the phone should be away. So what do we get then? There's step 1. Step 2, we've got our negative 2. Can we break this thing up? Travis, what do the numbers have to multiply to? If I'm going to break this thing up here. Which one do they have to multiply to? 10, good. So they're going to multiply to 10 and add to 11, good. What numbers do that? Multiply to positive 10 and add to positive 11. 10 and 1. Okay, good? Got it? Okay. Okay, what about this? There's some language here that's a little different. We want to talk about this for a second. You're going to get some questions like this too. So this is a review of some things you talked about in Algebra 1, but I don't know, maybe it never made sense. It's going to make sense today, though, if it didn't. So when it asks you to find the zeros of a function, right? Here's our function. What does that mean? Zeros of a function. Now, if we write this in function form, I'm going to write it like this. We're going to write it in function form. Remember, that's f of x. F of x equals x squared plus 14x plus 45. Okay? I'm going to pull up Desmos, and this helps. So let's graph that function. In Desmos, if you use the Desmos graphing utility, which we're going to start using a lot of real soon, I just type it in as f of x equals, and I'll just type that, x squared plus 14x plus 45. That's what I get. Oops, I did be plus. Uh-oh. Okay, so it's over here instead. So there it is. Okay? So there's the function, right? It's got a graph. Now, when I have a function, remember that f of x is just a fancy name for what? For y. Yeah, remember from Algebra 1. F of x is just a fancy name for y. All it's doing, say it again.
Why'd they make it?
Why'd they make that? Because when it's written this way, it actually has a little bit of extra meaning, right? So we know that, we just summarize that right there. So y is equal to f of x. But when we write it like this, that's called function notation. Those parentheses don't mean times, they mean of. This is saying f of x is equal to this. What in the world does that mean? It means it invites me to input values of x, and this is the formula I'm going to use to calculate values of y. So for example, if I wanted to calculate f of 1, what does that mean? I'm putting 1 for x. That's it, right? I'm just going to evaluate this thing when x is 1. So if x is 1, what's this term going to give me? 1 squared is 1. 14 times 1 is plus 45, so I'm going to get 1 plus 14 plus 45 is 60, right? So f of 1 equals 60. What does that tell me about my graph? When x is 1, what's y equal to? 60. So let's look on the graph. Where'd it go? There. Okay, so when x is 1, I'd have to go way up here, so I have to zoom out. But when x is 1, way down here, look. How about that, right? I can even show that on Desmos. So on Desmos, I could do f of 1, and look what it gives me, 60. Okay, I could graph a point. If I put parentheses here like an ordered pair, and I do 1, and I could even not even put 60, I could put f of 1 for the y value, and look what it does. It gives me an ordered pair at 160. There's the graph of that. Pretty cool, okay? So now, if we want the zeros of a function, what do you think the zeros are?
0 on the x-axis.
0 on the x-axis. Well, so 0 on the y-axis, which means the x-axis. I think that's what you meant, right? So it doesn't mean that we're plugging in 0. It means that we're trying to find the values of x that are going to make this whole thing equal to 0, that are going to make y equal to 0, right? Where do those exist? Well, we can see them. Let me zoom in a little bit. There they are, right? Those are the zeros. Those are the places where, notice that the y-coordinate is 0, right? So if we want to find those, well, the graph tells us the x values are -9 and -5, right? How could we find those without the graph, though? Okay, without the graph, here's our function. Aren't we just asking the question, when does f of x, which is y, equal 0, right? So y equals f of x, and f of x equals 0 when all of this stuff right here when all of that stuff, there's f of x, right? When that is equal to 0. So what does that mean? That gives us an equation to solve. We're just going to set the function equal to 0, and now we can just, what I call, move into algebra mode. We can just shift into algebra mode and just do the math. Now we know what we've got to do. Now let's just do it. Right? We know how to do this. This is one where I would factor it, wouldn't I? I've got x squareds and x's, so I can't isolate x, so I'm going to try to instead factor it and use the zero product property. So we'll look for magic numbers. Okay, are there magic numbers? They'd have to multiply to 14, or 45, and add to 14. 9 and 5. So by the zero product property then, and remember what the zero product property is, right? That's the little game we played yesterday.
I didn't like that.
You didn't like that game, right? And I'll even make the rules easier. You know, I've tried that. Nobody was any good at this all day long. Tell them to tell me what one of these numbers are. Nobody was any good at all at that first game. Nobody could tell me either one of those things. Nobody all day got them right. Remember, those were -16 and -4, but there's no way of knowing. But this one's easy. What's one of those numbers for sure?
0.
It has to be because they multiply to 0, right? So there has to be a 0 in there somewhere. Well, there it is, right there, right? So we're going to use that zero product property here to solve this equation. So the product of x plus 9 times x plus 5 can only equal 0 when we're multiplying by 0. So let's take the first factor, for example. How do we make that one 0? Okay, well, so what x value would I need? -9, right? I'd need x to be -9 to make that 0. Everybody agree? So there's one solution. How about this one? To make that factor 0, x would have to be -5. Okay? So that's what a 0 means. We're just going to set the function equal to 0 and solve. Okay, last one, and then you're going to work. So what about this guy? What if I wanted to, this time you're just asked to solve an equation, but that one looks weird. It looks pretty messy. I've got x squareds and x's and numbers on both sides. What do you think I have to do before I can even start this one? Say it again. Combine like terms, because I've got to get something equal to what? What's the magic number that one side of the equation has to be equal to? To use the zero product property, it better be equal to 0. Yeah, we got to put it in standard form, which means we're going to set it equal to 0. Right? So which side, now, and the answer is either way, but there's one that's slightly better. In which direction should we move all the factors, or all the terms? Push them to the left or push them to the right? Push them to the left, because the rule is we always want a positive number of x squared. That makes life a lot easier in the next few weeks, right? So we're going to move everything to the left. So what does that mean I have to do to both sides? Add what? I'm going to have to, what about the x squared? I got to add 4x squared. So those cancel. I've got to add 4x. And I've got to subtract 9, right? And that's going to give me, what, x squared plus 11x plus 24 equals 0. That's important, right? It's got to be equal to 0 for us to use the zero product property. Okay? So a quadratic equation in standard form, in fact, looks like this. Just like before, we've got the ax squared plus bx plus c, right? X squared's first, then the x's, then the c's, but it's got to be equal to 0. That's a quadratic equation with an equal sign in standard form. It's equal to 0. Okay, well that's easy now, right? Now this is something we can deal with. This is one we can solve by factoring, right? So what are the magic numbers going to be here? Good. So we're going to get 8 and 3. So what are going to be my two solutions then? -8 or -3, right? Make sense? It's a lot of math really quickly. Go, grab a Chromebook and get working.